Hi everybody, welcome to section 10.2a. You may notice there was no 10.1. We're not going to be doing section 10.1 right now, which is graphing radicals. We'll save graphing for later. I know you guys are a little bit graphed out right now. So let's talk about a few review problems before we start talking about 10.2a, simplifying radicals. We're actually going to split 10.2 into 3 days, an A, a B, and a C. And notice our little objective here. It says we're going to use the product property of square roots. So hopefully you remember what product means. First of all, do you remember these review problems? What is the square root of 25? Or remember we'd ask, is 25 a perfect square? If so, what is its square root? How about 121? Everybody remembers that that's a perfect square, right? That's a little tougher. Hopefully you know that square root button. 196, do you know the square root of 196? Don't leave. Class is not over. If you just took that minute to do your calculator, square root of 196, it should be a 14. So let's talk about radicals. A radical expression is an expression that contains a square root. It's actually got a square root in it. It might have variables, it might have coefficients, it might have, numbers inside or outside that square root sign. Notice it is an expression, it's not an equation. We'll solve radical equations later on. The radical is the real name for the square root sign. The radicand is the expression that is underneath the radical. So over in this little example I've got over here, I've got my radical. I've got a 6a underneath the square root sign, so that would make that the radicand. And I've got this 5 sitting out in front, just like anything else. That is a coefficient. Remember, the number in front of a variable is called the coefficient? Well, the number in front of a radical is a coefficient. And the index. We are always going to take a square root. Square root says the index is 2. Remember how the opposite of square rooting and squaring? They go opposite and undo each other? Well, our index is 2. That's the root that we're taking. And we don't write it. It's kind of like the default on a computer. It's Times New Roman 12 point or whatever. Default is 2. We don't even think about it. So there's 3 rules when simplifying radicals. The first rule is you cannot have any perfect square factors of the radicand. So in other words, we have to look at the radicand and break it down. Second rule is there are no radicands that are fractions. We'll talk about that in 10.2b, I think. Can't remember. Sometime in 10.2. And last but not least, you've got no radicals in the denominator. So we'll deal with those other 2 things. We're going to deal right now with the first red one. There are no perfect square factors of the radicand. So before we can start taking care of that issue, let's look at the product property of square roots. Here's the rule. If you've got a square root of some number, you can make that into the square root of the factor times the square root of a factor. So what you're going to do to simplify is you're going to find factors that are perfect squares and break them down. So think back to that square root of 25 that we did right at the beginning. What if instead of 25 I gave you a square root of 50? Is 50 a perfect square? Is there a nice, neat, perfect square that goes into 50? You would tell me yes, right? You would say, yeah, sure. That's 25 times 2. Notice we just followed that product property rule. We said, okay, we got a square root of some number 50. Well, that's the same thing as the square root of 25 times the square root of 2, because 25 times 2 is 50. But here's the thing. If we're going to simplify this, I would argue, and you might not argue back, that 25 is a perfect square, because what do you know is its square root? You know, its square root is 5, right? When I take the square root of 25, do I need a square root around it anymore? No, because I did the math. I actually went to my calculator, or I knew. This square root of 2 we can't do anything with, so we're just going to stick that on the end. You could put a times sign in between them, but we typically don't, because when we know there's a number next to something else, usually it's a variable up until now, we know it's multiplying. So that's what I'm talking about when I say we're going to find factors that are perfect squares and break it down. So your work will look exactly like that one that I put today. By the way, I'm expecting you to show the work in the same way as well. So I put a little list of perfect squares on your note sheet. Feel free to look. Basically, the number out in the front here, the 1 squared, 2 squared, these are the square roots. So what we're going to do is we're going to look to see, like 1 to the second power is 1, or in other words, the square root of 1 equals 1. 2 to the second power is 4, or in other words, the square root of 4 equals 2. So do you see where my 1, 2, 3 stuff's coming from? When you are looking, just like the problem that we just did, when you are looking for what numbers to break up, look for factors that are perfect squares and break them up, you're going to go down this second column right here that I'm going to ask you to fill in as part of finishing up these notes. So we know that 3 squared is 9. If you want to write on the side the square root of 9 equals 3, you can. If you don't want to, because you see how this little table is working, you don't have to. 4 to the second power is 16, or you would look for 16 to see if it's a factor. So when you go to break down your numbers, you're going to go to this second column right here, and you are going to check if these numbers are factors of what you are trying to break down. You don't care about any other numbers except for 1, 4, 9, 16, 25, blah, blah, blah. 1, actually, I skip it every time because 1 doesn't do anything for us, so don't even worry about the 1. Start with the 4, 9, 16, 25, blah, blah, blah. So that's what we're looking for when we are finding factors that are perfect squares. Does that make sense to everybody? All right, so let's do a couple examples. It says, simplify. Your answers may have a radical. Nobody is going to go to their calculator and give me a decimal answer. No decimals allowed. So I don't want to see any decimals on anybody's paper. Your answers may and probably will have a radical. So 12, is 12 a perfect square? If you type in your calculator, do you get a nice neat number, or do you get an irrational? You get an irrational, right? So now you need to take a minute. You need to go back to this list of perfect squares that you've got right over on the side of your paper and start going through. Is 4 a factor of 12? Is 9 a factor of 12? Is 16 a factor of 12? Is 25 a factor of 12? Well, once you get to the number, larger than the number, it doesn't work anymore anyway. So really, we're going to look for 4 and 9, and we all know that 4 times 3 is 12. So when you write this out, you're going to write 4 times 3, but both of those numbers need to be underneath a square root because we're looking for the square root of 12. So which one of the numbers is a perfect square? And what is its square root? Cross it out. You're going to tell me the square root of 4 is 2. The square root of 3 we can't do anything with because it's not a perfect square, so our answer is 2 square roots of 3. And we are done with that problem. So let's try a 90. 90. So, first of all, is 90 a perfect square? That's what I asked myself first. Let's make it easy on ourselves. It's not, right? Is there a perfect square that goes into 90? So I'm going to my list. Does 4 go into 90? Does 9 go into 90? Aha, it does, doesn't it? 9 times 10. And remember, my 9 times 10 both go underneath the square root sign, Which one of those two is the perfect square? Excuse me. 9 is, what's its square root? What do we do with the 10? Keep it underneath the square root, put it next to the 3, so our answer is 3 square roots of 10 for our final answer. 450 is a little large. Let's go over here to F. 45. Is 45 a perfect square? It's not, right? Is there a perfect square that is a factor of 45? Does 4 go into 45? Nope. Does 9 go into 45? Yes, it does, doesn't it? 9 times 5. Notice how I'm showing my work. That's how I expect you to show your work as well. What is the square root of 9? We did this one in the last one. And can I do anything with the square root of 5? Nothing except to bring it down and stick it on my answer. So my answer is 3 square roots of 5. Let's talk a little bit about variables. So you can also take the square root of variables. We've actually done this already. Remember back when we were doing factoring and I'd say, what's the square root of x squared? And you would tell me x, right? You know a variable is a perfect square when, there it is, the exponent is an even number. So for example, x to the 4th power. If I asked you for the square root of x to the 4th power, or in other words, what times itself would give you x to the 4th power? You would tell me it's x squared times x squared, right? Really, the little sneaky thing is we're going to break that variable into groups just like I just said it. So really, before I put that answer down, I should say that's the square root of x squared times the square root of x squared. Square root each piece, that's x times x. But quite honestly, because it's a nice even variable, you could skip right to that because we know how to do that. You can think to yourself, what times itself gives you an x to the 4th? So if you skip that green step with the x squared times x squared both underneath the radical, that would be okay. Here's the question though. What if it's not a nice even number? So we just did A. Let's jump down here to C. I've got a square root of a squared times a square root of b to the 5th. So I'm going to say, all right, that's a square root of a squared and a square root of b to the 5th. This is what I'm looking for work from you. Do you know the square root of a squared? What times itself would give you an a to the 2nd power? That'd be just an a or an a to the 1st, right? B to the 5th we have to break down. Remember how I mentioned the variable has an even exponent? What if I asked you for b to the 4th times b to the 1st, both underneath the radical? Could you tell me the square root of b to the 4th? What times itself will give you a b to the 4th power? B squared. Can we do anything with a b to the 1st? Is there anything that's times itself that will give you a b? Nothing. So we have to keep that on the end of the answer. Let me move these guys down. It's a little crowded in here. So it feels weird to leave that square root around a variable in our answer, but it is correct. So let's look at D just to make sure we got a good practice down for these variables. So D, I've got a D to the 11th times an E to the 13th. So the first thing I'm going to do is break that up so that each variable gets its own square root sign. Is D to the 11th a perfect square? It's not, right? Because it's an odd number where there's nothing times itself. So if I asked you to break that up into one that is a perfect square and one D power that is not a perfect square, I think the easiest one to do would be D to the 10th times D to the 1st. Hint, always make one D to the 1st and subtract to get the other D exponent or whatever variable. So what's the square root of D to the 10th? What times itself will give you D to the 10th power? That'd be a D to the 5, right? Can we do anything with this square root of D to the 1st? Just like that last problem, the B, we're going to have to leave that sitting underneath the square root all by itself. How about an e to the 13th? Is that a perfect square? How would you break it up? If one of them is an e to the first, the other e power will have to be. And what is the square root of e to the 12th power? And don't forget about the square root of e to the first. Well, these guys can go underneath the same square root sign. So my answer, as long as my d and e, the leftovers, are both under the square root, I've got d to the 5th, e to the 6th, and a square root of dE. So this will be my final answer. So now let's work with the numbers and the variables. We'll do a couple problems and then we'll stop. Let's do B. Let's do B and C. So B, I've got a square root of 81, a to the 3rd. The first thing I'm going to do is split up the 81 and the a to the 3rd. Let's deal with the numbers. Let's deal with the variables. Let's not try to do everything at once. Is 81 a perfect square? Nope. What is its square root? It'd be a 9, right? There are no numbers left under my radical. Is a to the 3rd a perfect square? Let's break that up. If one of my a's is a 1, the other has to be a squared. So what's the square root of a squared? And is that going underneath the radical or in the front on the outside? And you could put it to the first power. The only thing that needs to stay left underneath the square root is an a to the 1st or just a plain a. So my answer is 9a times the square root of a. How are we doing with these? We'll put all these numbers and variables all together. Last problem, 72 d to the 8th power. So of course I'm going to break this up into a 72 into a d to the 8th. Probably could do the d to the 8th right now, but let's do the 72 first. Is 72 a perfect square? No, it is not. So does 72 have a factor that is a perfect square? This is a trick problem. This has two numbers that are factors that are both perfect squares. Pick the biggest one and you'll save yourself some work. So I'd be willing to bet there's some people out there telling me 9 times 8. So let's do 9 times 8. Because we're going to have to do some more work. And then I'm going to ask you what the better number to use would have been. So which one of those two, 9 or 8, is a perfect square? What is its square root? 8. We can't do anything with, right? But I'm going to think to myself, is there a perfect square that goes into 8? There is the very first one, 4 times 2. Huh. So that's interesting. I could have written that square root of 8 down here, and then I'm going to think to myself, can I break that down again? Yes, I can. So I didn't even rewrite it. But here's the question. Which one of those two, 4 or 2, is a perfect square? Notice I crossed these things out so that I don't get confused that I have used them already. 4 is a perfect square. Its square root is 2. What am I going to do with the 2 I just got and the 3 that I got earlier? No sign in between things, remember? Times those guys. So 3 times 2 is 6. And then I've got myself a square root of 2. I'm going to leave a little space because I'm going to remember that my d's have to go in there too. We always write our numbers that we've square rooted or taken out of the radical out in the front. Otherwise it gets confusing what goes where. So is d to the 8th a perfect square? It is, isn't it? What could you times by itself that would give you d to the 8th power? D to the 4th times d to the 4th. So we know the square root is d to the 4th. So my final answer for C is 6d to the 4th times the square root of 2. Just a quick thing, I don't write it like this about the feedback because sometimes it does get confusing what's underneath the square root and what isn't. So I'm going to stick to that, writing it like that. All right, so we're to your favorite part, the lesson summary and the practice problem. Remember, these need to be done when you start class in order to get full points for your notes. So the lesson summary, explain in your own words how to simplify a radical. For example, this one over here, the square root of 18x. Or you could just use a general example. What do you look for? How do you do it? Where do you go? So explain how to simplify a radical, and then please just go ahead and square root or simplify the square root of 18x to the second power. Have a great day. We'll see you next time.